Okay, guys, we are going to be going over functions today. So let me share my screen. This is chapter 6. And chapter 6 is called functions. Okay, so modular programming. Modular programming means breaking a program up into smaller manageable functions or modules. So anytime that you're solving a problem, just in real life, you like to break things apart into smaller parts so that you're able to tackle a big problem. So whether you're working in construction or you're sewing a dress, you want to break things into smaller parts so that it's not such a huge task and you're not trying to do everything at once. And so we do this in programming with functions or methods. In C++, we call them functions. And a function is just a collection of statements to perform a task. So we put a collection of statements like cout, cins. We can put, we can do calculations, and they're combined or grouped by something that is alike. Motivation for modular programming improves maintainability of programs. So this is nice when you're creating really large programs. You can easily maintain a program by taking a function, and if you have a function that needs to be updated, and let's say that same function is used across 10 programs, you just update that one function and then it's going to be the same across 10 different programs. It also simplifies the process of writing programs. So if you have something that happens over and over again, you can put it into a function and just call that function over and over again. For example, there's a function that C++ comes with called square root. And you don't have to create the function, you just call the function every time that you need it. And so a lot of times when we see that there's a pattern of needing to repeat certain pieces in certain areas in our program, we'll create functions and then call that function whenever we need to do that. So just an example would be if we created a function for login, let's say that we have lots of programs and that all require logins, we can call the same login for all our different programs. We just need to create it one time, and the login program is going to have all those features like checking the password, the username, not letting them enter it more than X amount of times, etc. So here in this slide, we're looking on the left-hand side, we have our main function, and then we have all these statements. We have statement. And so here we've taken this program and we've divided into 1, 2, 3 functions. And so we call the first function, well, it's not even called yet, but we have the main function, and then we have other functions that we can call, and then we have statements within those. It doesn't really kind of show you too much there about how we do this, so, but it's basically just breaking it into smaller functions. But these functions here, function 2, 3, and 4, they're going to have to be called from main. They're just not showing here that they're being called. Okay, so in section 6.2, we're talking about defining and calling functions. So whenever you define a function, you have a function definition. And the function definition is going to have a name. So for example, here, the name is function 4, and then it's going to have the statements inside the function. And then you have to call the function. So You can't just create it and not call it. If you don't call, you can create them and not call them, but then they'll never execute. And then you'll call those functions either from the main program, or you can call a function within a function. So a function can call another function. All right, so what does a function definition include? Well, let me just show you. It's better for me to show you than just to read this right here. So let's say that I have a function that it's going to require you to, it's going to add up two numbers. So I'm going to call it the sum function. And the sum function is going to receive two numbers, num1 and num2. And it's going to return it's going to return the sum of num1 and num2. Okay, make this a tiny bit bigger so you can see it. Sorry, that was my son. He's making a lot of noise. So this here is what we call the definition of our function. So the definition of the function has a return type, a function name, a parameter list, and the body of a function. Okay, so what does the return type look like? Well, the return type depends on what you're returning. You can be returning an integer, you can be returning a float, a double, somebody's name, whatever it is you're returning, then that's going to be this data type. This data type has to match whatever this is. Your parameter list here, it can be anything. It could be empty. You don't have to pass the function anything. Or it could be, for example, let's say that I have a function that just, I'm going to call it header function. And all this function does, or title, like title. And all this function is going to do is just going to see out program or something, you know, like, that's a good title, right? All right, so the sum program. So this function here has no parameters. The parameters go inside the parentheses. It's a void function, meaning there is no return. I'm not returning anything. I'm just going to see out the sum program. Now, our functions are actually defined outside main. So I'm going to put them out there. They're not inside the main function. All right, so we've got, just a second, move this bar away. Okay. So here we're talking about, they're talking about a function header. So the function header is this here, this whole thing right there is the header. And the header has to have the return type, which can be void, the name, and the parameter list. The body has the open and close curly braces. We talked about the return type. Here's one that doesn't have a return. It just prints out monthly sales. Okay, so now let's call the function. So in my little example here, I have void title and int sum. To call the function, I can call functions from main. This is one place I can call them. So this one doesn't have a return. So I'm just going to write title. It doesn't have any parameters and open and close parentheses. For the next one, when I call the function, I've got to pass it two things. I have to pass it two numbers so that then the function returns to me the sum. And it's got to return it somewhere. So what if I say int sum, int total equals, let me not do all that. just to simplify it. So total is a variable, and this total variable is going to hold this sum. And I'm going to pass it to number 5 and 10. Okay, so I'm passing it a 5, which is an integer. I'm going to pass it a 10, which is an integer. It's going to add 5 plus 10, and it's going to return that value to this variable called total, which is also an integer. Okay. All right, so that's calling the function. Now, here they put the function at the top. So let me go ahead and do that, because if we put the functions at the top, then we do not need what's called a function definition. Okay, so let's put them at the top. If I don't put them at the top right now, it's not going to run. It's going to give me an error. And the reason being, so if I take this and I put it at the bottom here, when the program compiles, it's going to compile from top to bottom, right? And so it's going to see this function called title. It's going to say, well, I don't know where this function is defined. It's not defined in IOStream. It's nothing that it's seen before, so it's going to get confused, and it's going to give you an error right there. So there's an error, and it says use of undeclared identifier. So it says title is not declared, right? So now what I'm going to do is I'm going to move it to the top, and it's going to be able to. Oh, I don't know what I just did. Grab everything. There we go. Okay, so here's title. Now it's going to define that first. It's going to define this, and then it's going to use it. It's kind of the way I think about it. It's like if you have like an unknown vocabulary word, like let's say you don't know the vocabulary din, D-I-N, and you use it, and it's like you can't use it unless you know what it is, right? Unless you know the definition of it. So you've got to know the definition before you use that word in your paragraph, if that makes sense. Okay, so now we run it, and I have some kind of error. Let's see what kind of errors I have. Oh, so my first error is here, and it's telling me that num2 does not have a data type. It says unknown type name num2. Oh, I forgot to put int right there. Okay, so now let's run it again. I remember anytime I fix one error, I don't look at the next error. I just run it again, because sometimes fixing that one error fixes the other error. Okay, now it says, oh, the name of my function is not, oh, I didn't, wait. Oh, I see. So the error says expected semicolon after the expression. So see right here, there's no semicolon. And now I'm going to run it again. And then it prints the sum program. So we called it title, and it printed the title, the sum program. And then it returned sum to total, but I didn't print it. So that is not going to help. It's not going to let me see what's inside. So let's see out. Sum is total. I could do this. I can also do this. See out. The sum is sum. And I'm going to give it two different numbers, 10, 10. So I can call a function within a cout statement, I can call a function and assign the value to it. See right there, I'm assigning it. So I could do it either way. I can also call a function and then add something to the value that it returns. Oh, I forgot to put inline. Add an inline here so that it's easy to read. Okay, so title, first we call title, and it prints out the sum program. So title takes me up here and it outs the sum program. Then the next line is total equals sum 5, 10. So the 5 and the 10, the num1 gets a 5, num2 gets a 10, 5 plus 10 is 15. The sum is 15. Then it calls the function sum again, and it passes a 10 and a 10, and it says the sum is 20. So 10 plus 10, the sum is, and then 20. So this returns the 20 and puts it here. This returns the 15 and puts it here when it outputs the numbers. Functions are not the easiest thing to understand. So you're gonna have to do a lot of coding and trying things out to really understand functions. I still remember trying to learn functions and think how confusing all this was. So believe me, it took me a while to understand all of this, okay? But the best way to understand it is to just go in there and code. It's like trying to play a piano. You can't play a piano by watching a video and watching somebody else play the piano. You've got to play the piano. All right, so this is some examples of our functions. Here is an example of the display message function. So it first outputs hello from main. It then displays the message hello from the function display message. Then it couts back in function main. So this is a nice little program that you can type in and try out. Main can call any number of functions. Functions, like I said, can call other functions. The compiler has to know the name of the function, the return type, the number of parameters, and the data type of each parameter to be able to call the function. So here, earlier I got an error because these functions were defined down here. So it didn't know what the word sum was. It didn't know that this was a function until I moved it up here. So what if I don't want to put my functions up here? So I don't. Typically, your functions do not belong there. Your functions belong here. In a real coding environment, you would have a separate file that contains what I'm about to show you, okay? So typically you have, not typically, but always you have your functions under main. Main comes first, then your functions. You have a separate file that contains your function prototypes. So what is a function prototype? So function prototype is a way to let the compiler know that you're about to use some functions at the bottom. And so your prototype is going to look like this. So basically what I like to do is I just copy this. I copy the header. I put it up here. So these are going to be my function prototypes and a semicolon. And then the next one is called int, this one, semicolon. Now the prototype doesn't need to know the names of the variables. It just needs to know the data type. It doesn't care about the names, it just cares for the data type. So it needs to know that this function sum, it's about to get a function called sum. It should return an integer, and the function should receive 2 parameters. That's all it has to know. It doesn't have to know anything else. Where does it find the function? It knows to find the function down here. So here's an example. We have void first, void second. We called first function, we called second function. And then here's what we define what the functions do. Prototype notes. Place prototypes near the top of the program. Program must include either prototype or the full function definition. So either put the full function at the top or put the prototype. When using the prototypes, you can place function definitions in order in source file. So this third option is what we typically do if you're working for a company and you have a real program, all your functions will go in a source file, will go in a different file, and then you include that file up here at the top. You include it there. Sending data into a function. So this is something that I just showed you how to do, how to send data to functions. We just list them here in the parameters. Here they're showing you the pow function. This is the power function, so raising a to the power of b. And this function is in the math header. The a and the b are called, the a and the b, when you pass them, are called arguments. So let me show you here. Okay, so here, the 5 and the 10, these are called the arguments. Okay, so I'm passing a 5 and a 10, and then here, oh, can't move it. Okay, so then here, these two here are called parameters. So these are called the arguments where you call the function. And then these are called arguments. So we have arguments and parameters. A function with a parameter variable. So here's a function, they pass it. It has a parameter, has a one number that's going to be passed to it. So here is our function prototype. This is a function that doesn't return anything. It displays the value, and you have to pass it an integer. Here we call the function by its name. It has to be exactly the same, lowercase display, capital value. Has to be spelled exactly the same. It says this function has to be passed an integer. Here we're passing it a 5. We go and we call the function. Well, what does the function do? The function takes that 5 and it displays the value is 5. So type that one in, run it. You can see how it runs. Again, this is called the argument. This is called the parameter. This number 5 gets sent to this variable. Now, one thing that happens is that this number 5 here, so we call this the argument. Let's write it again, argument. You need to know these words, argument. This is called the parameter. Here, you're defining the variable num. So num is going to be created in memory. It's going to take up space. It's going to have a memory location. And num, it's going to get assigned the 5. So in memory, you're going to have this variable called num, and it's going to hold a 5 in it. And this 5 is only going to be there in this function. Remember we talked, I think it was last chapter, about scope. Well, the scope of num is this function. When you go back to main, this variable will not be able to be used unless you define it up there, and it's not going to have the value of 5. So 5 only lives here in num. Okay, other terminology, we have something called a formal parameter and a formal argument. So parameters can be called formal parameters and formal arguments. And arguments can also be called an actual parameter or an actual argument. I would not worry about the terminology. Just remember argument and parameters for now. Okay, arguments and parameters. Make sure you know what a prototype is. What are parameters? What's a function header? So let's look at those here. Parameters, prototypes, function headers. And let's label those. So if I have this program, I say, okay, name the let's see if I can write on this. Okay, here we go. So parameters, which ones are parameters? These are parameters. So I'm going to write P for parameters. These are your arguments. I'll write A for arguments. This is your function prototypes. So we have 2 function prototypes. Okay, function prototypes. Then we have 2 function definitions. So this is a function definition here. This is a function definition here. Okay, this is what tells us what the function does. It's defined. This here is our function header. That's the header of our function. This is the function body, header and body. So just some terminology to make sure that you go through, label these, label the arguments, label the parameters, label the header, the prototype, the definition. Those are things you need to study. To my mouse. Value of argument is copied into parameter when the function is called. I showed you that earlier. So when you call the function, that 5 got copied to the variable num. And the scope is the function itself. That's the scope. Function can have multiple parameters. Yes, I showed you that here. We had 2 parameters in this function called sum. You can have as many parameters as you want. There must be a data type listed in the prototype and an argument declaration in the function header. So what does that mean? So it has to be, there must be a data type listed in the prototype. Okay, look at the prototype. This is the prototype right here. And it tells us the data. So data. Don't have to have the variable names, just the data. If you have the variable names, that's fine. It doesn't give you a problem. You got to have the data. Then it says argument declaration in function header. Well, where's the function header? This is the function header right here. And we've defined, here you do have to have the name of the variable. Define variable num1, define variable num2. They're both integers. And our prototype has 2 integers. Passing multiple arguments, we just showed you how to do that, how to pass both arguments. Here's an example. This one has 3 arguments. Show sum. Here's a prototype. This function is a void function, doesn't return anything. The name of it is show sum. It returns, it takes 3 parameters. Int, int, int. So this program will ask the user to enter 3 integers. The user enters 3 numbers. The 3 numbers get passed to show sum. Here, show sum. We pass the first number to num1, num2, num3. It adds up the numbers and it displays them. So if the user enters 487, this program is going to see out 4 plus 8 plus 7, which is 19. So it displays a 19. So here's the function call, show sum. Value 1 goes to this variable, value 2 went to this variable, value 3 went to this variable. By the way, looking at this program, so here we've got value 1, value 2, value 3, but guess what? We're creating 3 memory locations here. 1, 2, 3. So we're in memory. There are 3 memory locations. The numbers that you enter right here, see where it says CN value 1, value 2, but whatever you type in, it's going to be saved inside these boxes. So let's say we type in a 1, a 5, and a 3. So those numbers are inside value 1, value 2, value 3. These numbers, the 153, now get sent to the function. And the function is, so right now you've got value 1 has a 1, that has a 5, that has a 3. Those 3 numbers are, you got 3 variables. Then guess what happens? 3 whole new variables get created. So now we have 3 whole new variables. And I'm going to put these up here. These are going to be value 1. I'm going to name them again. What happened to my... Okay, so I'm just going to say value V1. This is V2. And this is V3. So those are those 3 variables. And these 3 variables, V1, V2, V3, the scope is in main. So the scope is not here in show sum. You can't say see out value 1 in here. No. You can only use num1, num2, num3. So now we have 3 whole new memory locations. Num1, num2, num3. Change colors here to green again. The 1 gets passed. The 5 gets passed to here. And value 3, which is the 3, gets passed to this one. So we have 6 memory locations. These variables, num1, num2, their scope is what? Their scope is show sum. You could only use those variables in show sum. V1, V2, V3 can only be used in main. Value 1, value 2, value 3. So here's value 1, value 2, value 3. Can only be used up there. Okay, let me erase all this. So we have multiple arguments, value 1 gets passed there, value 2, value 3. Okay. This is going to be fun. Again, functions are confusing. So now we have something called passing by value and passing by reference. This is even more confusing, okay? You really need to type this up or it's just not going to click. All right, passing by value, passing by reference. So let me make up two variables here to show you what this means. Int num, int n1, n2. I'm going to assign n1 to 5, and I'm going to assign n2 the 10. Here, instead of putting 5 and 10, I'm going to put n1 and 2. All right. So if you pass a number by value, so passing by value, let me write that down. I'm going to slow down because I tend to talk very fast. So passing by value, annotate. Let's change it to blue. Value. What that means is what we said earlier. We make separate memory locations. There's a memory location in main and there's a memory location in sum. So here we create two memory locations, one for N1, one for N2. So we have N1, N2. So I want you to imagine memory, all this memory. Think of a brain, right? Computer has memory, and our memory is like our short-term, well, yeah, it's basically short-term memory. So it's memory that as soon as you turn off the computer, it's just boom, it's going to go away. I think our brain works that way until we put it back into long-term memory. So the 5 and the 10 are going to be stored here. So 5 goes in N1, 10 goes in N2. Okay, so it has some memory location, some number. When N1 gets right here, here we would need to change this to N1 and N2. So let me do that. N1, N2. All right. So when that N1 and N2 get passed to these two variables, two more variables are created. So the variables that get created are, I'm going to write them over here. Num1 and num2. Okay, so num1 and num2. So num1 is going to receive the 5 and num2 is going to receive the 10. And we have 4 different, so this goes from here to this memory location, and this one goes to this memory location. So it goes from here to here, here to here. This is passing by value. We're taking the value, we're just giving it to the function. Here's my value. Okay. I still have access to N1 over here. I have access to num1 over here. I don't have access to N1 here, and I don't have access to num1 and num2 here. Okay, so that's passing by value. Passing by reference is different. Passing by reference, you do not create. I'm just gonna, not that, I'm gonna just erase. This doesn't happen. This doesn't happen. This doesn't happen. Okay, so now I'm doing reference. Reference. When you pass by reference, what looks different is that you have an and sign right here. And you have an and sign right there. And what reference means is that when you pass N1, this 5 to num1, you're not making a copy of, and you're not creating a whole separate, you're not making a whole separate separate memory location for this. So num1, what num1 is going to hold, so let me just draw here what num1 holds. Well, you are making a whole separate, okay. You are making a separate memory location, but okay, this is supposed to be num2, but it's not holding a 5 and a 10. What num1 or num2 are going to hold, it's going to hold the address of these two. So let's say that the address for this one, let me change the color here. Address is usually a hexadecimal number. And I'm just going to write like the last 4 numbers of a hexadecimal. FFE0. Let's say that this one's stored at FE. Just another FE. E. Okay. So what these store are the references. So the address FFE0. So the memory, like it tells me where is this found? Sorry, this is taking forever. So what that means is that because it does that, now I do have to add ampersand there, ampersand here. What that means is if I say something like num1 equals 6, num2 equals 3, then guess what's going to happen? Well, not only it's not changing num1 and num2, it's going back to this memory location. It's going to change this 5 to a 6, and it's going to change. So this becomes a 6, and num2 becomes a 3. Okay, so we've got, because it's a reference parameter, I'm not changing num1, num2, I'm changing n1 and n2. And n1 and n2, you just have to think of it, they're the same. Num1 is the same thing has the same address as n1. Num2 has the same address as n2. And so we can see this if I run this program. So we're starting with 5 and 10. I call the function, I change it to 6 and 3. So how about we show, when we come back from the function, we show, let me clear all this first. Clear all drawings. So when we come back from the function here, I'm going to see out n1 is, n2 is And then I'm gonna do the same thing before we start. So before I call the function, N1 is gonna be a 5 and N2 is gonna be a 10. After I call the function, N1 is gonna be a 6 and N2 is gonna be a 3. And I'm not gonna call the functions here. I'm not gonna show those. I just wanna show what comes before, what comes after first, okay? With my reference parameter. Again, to show reference, we use the ampersand and ampersand right here. This is one error generated. Let's see what error it gave me. Oh, I didn't show N1 and N2, silly me. So N1 is N1. I could actually show the value. N2 is N2. N1 is display the variable. N2. Okay, now I should run. All right. Now I need to add more spacing so you can read a little bit better, but N1 is a 5 and N1 is a 10 when we start. When we call the function, we change num1 to 6 and num2 to 3, which means that N1 and N2 also change. So these also change. Let's put a space there. So we start with 5 and 10. 5 and 10 get displayed. We call the function, we change them to 6 and 3. 6 and 3 get displayed there. So that's a reference parameter. So reference parameter means that this is not going to hold the value 6. This is actually going to hold the address to where N1 is stored. Okay, so that's passed by value and passed by reference. Using functions in menu-driven programs. So whenever you have a menu, let's see if they have an example here of a menu-driven program. They do not. Okay, so when you have a menu-driven program, you want to implement functions for your menu-driven program. So for example, if you have a program and you have cout, so here's a menu, add 2 numbers. And cout, subtract 2 numbers. And and then so that this is option 1. This is option 2. And then option 3 is just to exit. If they wish. And then cout. Oh goodness. Cout. Choose an option. And then they would and then I would cin option. I would define option as an integer. And then, so this would, so right now, let me take this out, take that out. Okay, so right now, it's just gonna show my menu. Oh, Forgot a quote. So it shows add two numbers, subtract two numbers, exit, choose an option. I'm going to enter option 3, which is to exit. And when I enter option 3, it shows my title, the sum program, which I need to take out. I don't need that anymore. Maybe I give it a different title. But I can use functions to do option 1 and 2. So option 1 would be this sum. So what I could do is, here, let me just delete all this. So I could say, I could do a switch. I could switch an option. Or I could do an if statement. So if it's case 1 or option 1, then I would call the function, this function here, sum. So, oops. And maybe my function sum could actually ask for the values. Like I would say, yeah, enter the numbers to add. In num1, num2. So this would be empty, so I don't need any of this. Or I could ask for this over here, for the two numbers. Either way. I think I'm going to ask for the two numbers. So first, I don't want to make them reference. So I'm going to ask for the two numbers here. So add two numbers, subtract two numbers, 3 to exit. Okay, so if it's option 1, you do it this way. And then you pass the two numbers here. So you pass num1, num2. It passes the two values to this. You can return the sum. So you could say like CL and then sum is, and then this would be the sum. So right now I'm just going to do one case, and well, case 3 also would be just write that and exit. And I'm not going to do case 2 yet, so I'm not going to do subtract. The only thing I have left here to do is define num1 and num2. So I'm going to define that here. Num1 and num2. I don't have a function named title anymore, so I'm just going to delete it. And then let's run it. Let's see if it likes it all. And it says add two numbers. So here are my options. I've only coded case 1 and case 3. So let me make sure 3 works. 3 should just exit. It does. And then now I'm gonna try option add, which is option 1, add two numbers. Enter two numbers to add 3. Oops. I only entered one number. Okay, 3 space 4. Oh, okay. Got ahead of myself. Option 3 is to exit. Option 1, enter two numbers, 3 space 4. Oh, this sum, why does I sum is 89? 4, 5, 6, 7. Return no more. That's not 2. sum. Oh, oops. There we go. Yeah. So I forgot this right here. Okay, so let's try this again. Run 1, 3, 4. Sum is 7. Awesome. Okay, so we got sum is 7, and then I could do case number 2. In case number 2, I would create another function. I would call it difference. So we talked about the return statement already, how we return a value from a function. So we've done this, we've returned values from functions. So we have x equals pal. So this returns 2.0 raised to the power of 10. So we've looked at that. In here, we're returning num1 plus num2. So it returns the sum of num1 plus num2, just like our example. Again, this is a value returning function. So you've got no references. It just takes the values and creates 2 memory locations, num1 and num2. The scope of num1 and num2 is just sum. So these 2 variables can only be used inside this function called sum. This variable called result can only be used in this function called double. This is a value returning function. So just like the one that we did, an example, we're returning num1 plus num2, the sum. So this is just saying you can return an expression. You can do an addition here, or you can say x equals num1 plus num2, return x. So here we have value 1 gets passed to num1, this gets passed to num2, and the return value gets sent to this variable called total. Okay, just like the example that we did. Here we have a function called square. The function square takes one number, the radius. You pass it the radius, it returns number times number. Returns it here, multiplies it by pi, and it gives you the area of a circle. So this is the formula for the area of a circle, just in case you'd forgotten. Area of a circle, pi times radius squared. This is just different ways that we can return values from functions. So a function can return a true or false. If you return a true or false, it would be a Boolean data type. We can return integers, strings, doubles, whatever data types. So in this example, they're returning a Boolean. The Boolean, this function is just going to return if it's even, it returns a true. If it's not even, the number returns a false. So if the value is even val, C out even, L, C out odd. Let's go see what the function. So this function returns a Boolean, true or false. It takes one parameter. This function takes one parameter value. So it takes an integer. It takes that integer modulus 2. Remember, modulus 2 is it divides the number by 2, and if there's a remainder, modulus gives you the remainder. So 4 divided by 2 has a remainder of 0. 5 divided by 2 has a remainder of 1. So if this is a 5, 1 is not equal to 0. So it's going to return false, meaning that it's not an even number, it's an odd number. The last section talks about local and global variables. This talks about global variables, but do not use global variables in your program. I will take off points if you use global variables in your programs, okay? Unless I specifically say, create a global variable, just so that I know you know how to use global variables. In a real, world situation, the way that global variables are created is that they're created by somebody specifically in the company who says, actually, they're not even variables, they're global constants is what they create. So for example, a tax rate can be a constant because we know that tax rates, like sales tax rate, don't change for many years. And so the company has that set, that constant, and it's in a file, and there's certain things are in files and you just use in your programs so that there are no calculations messed up by you getting the wrong sales rate. Also, if you have a global constant, when the sales rate does change, then it has to be changed in one place only. And then if you have, let's say 100, 200 programs, all that use that tax rate, guess what? Boom, 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 boom. Everything is perfect. You know that your program is going to run fine and calculate fine. So a global variable is the variable that can that you define before main. You define at the very top of your program after pound include and using namespace. And once you define it there, you can use it anywhere in any function, main, and any function that you create. So this here is called a local. These are local variables. Option num1 and num2 are local to the main function. These two variables are local to the sum function. And by the way, even though this has the same name, this variable is called num1 and this variable is called num1, they have two separate memory locations. So they're not the same num1. It's just like there can be two Jeanettes, there can be two Joes. These live in two separate households. Household here is main, household here is sum. So these are two separate variables, two separate addresses. And so a global variable would be a variable that you could define here at the top where you have the prototypes, either before or after the prototypes. Doesn't matter. Global variables. Integer. Global 1 equals 100. So here I can see out 100. I'm sorry. I can see out global 1 and line. I'm going to go ahead and just put comments around this whole code so nothing of this prints out. And here I can also see out global 1. Because since it's global, oh, I've got to call the function, don't I? So let me call the function. Call the function sum. In total equals sum. So I call it 10. Okay. So I don't care about the sum. What I care about is to see if global will print here and global will print there. So global before I go into total and global once I go into, sum, the function sum. So I'm going to run the program. And so 100 is in global right here. So that first 100 is here in Maine. And actually, I'm going to say, I am in Maine. Then here, I'm going to say, I am in the sum function. Okay, run it. So I'm in Maine, 100. I'm in the sum function 100. It's global. I don't have to define it in sum. I can use it anywhere. But again, don't use global variables unless asked. Okay. It's just really bad because you can, when you have huge programs, global variables are bad because they can be messed up. Especially many programmers are coding the same program, like different parts of the program. Okay, so local and global variables. And we talked about global constants. All right, local variables only exist while the function is executing. When the function terminates, the contents of a local variable is lost. So again, it's just short-term memory. Static local variables retain their content between function calls. Static local variables are defined and initialized only the first time the function is executed. 0 is the default initializing value. So local variables do not retain values between function calls. So we have show local. So we have show local here, show local. So show local just says local num equals 5. See out local num equals 99. So when we come into here, it sets local num to 5, and we see out 5. See out the number. Then we change it to 99. And then when we print it, when we go back into here, it creates a whole new variable again. Local num, it creates a whole new memory location, and it puts a 5 in there. So every time you call the function, a whole new memory location gets created. So here, local num is memory location FFEE, the first time you call it. The second time you call it, another memory location gets created, and then another memory location gets created. So your number is going to go away. Whatever you have here is going to go away. It's going to get redefined. So here they're using a static variable. So they're creating a loop, and they're calling the function 5 times, show static. They define the function static int stat num. And every time it shows that they add 1, it shows 0, 1, 2, 3, 4. So basically, it doesn't create a whole new memory location. It just changes the same memory location. So it goes, the first time is a 0. So count 0, show static. So when the loop is 0, stat num is initialized to 0, automatically prints a 0. Stat num goes up to 1. We go back up here, we call the function again. We print a 1. We increment to 2. We call the function again because we're still in the loop, etc., etc. We print 1, 2, 3, 4. If you don't initialize a local static variable, the initialization only happens once. So here they initialize it to 5, and it only happens the first time you go into the function, then it's a 6, 7, 8, 9. So it keeps the value. Default arguments. So this is a default argument right here. It's an argument that is passed automatically to a parameter if the argument is missing. So if for some reason they call the function without a parameter, it's just automatically sends a value to it. So these are int, and then if a second value is not entered and a third value is not entered, then 0 is entered. So here's an example. We have int equals 10, int equals 5. These are the default values if nothing is passed to the function. So here, when you call the function display stars, it's going to use a 10 and a 1. Here it's going to use a 5 for the first parameter and a 1 for the second parameter. Here's going to use, it's not going to use a 10 or a 1, it's just going to use a 7 and a 3. And this is talking about reference variables, which I already went over on the reference variables. So I'm going to let you read that on your own. Again, you got to use the ampersand for the for those values. Some notes on reference variables: you got to use the ampersand. You have to have a space between the type and the ampersand. So int ampersand. You must use ampersand in both prototype and the header. And you have to pass parameters to your reference variables. Okay, so we're going to stop there. And then the last thing that we're going to look at is overloading the functions, using the exit function, stubs and drivers, and that's it. Okay, so that will be our next video. I think that's enough for now. And maybe in the next video, I'll go over a little bit more, just like a review, because functions are hard and reference and value parameters are difficult. Okay, guys, thank you.